Good afternoon, everyone. Just turned afternoon. We got our last talk before lunch today. Just before we get started, it's a little reminder, if everyone could ask questions via the app, it really helps later on. Ask questions at the end, or if we run out of time, you can catch the presenters outside. But our next presenters are from Melbourne, Monash University. We've got James and Andrew, and they're talking about On-Prem Ain't Dead, a deep dive into modern AD security techniques. So please welcome the guys.
All right. Hello, everyone. My name's James Spencer, and today I'm joined by my colleague Andrew Fitzgerald. We're both from Monash Uni down in Melbourne, and today we're here to talk about AD and securing AD in modern environments. So just quickly, my name's James Spencer, as I said. I'm in the security automation engineer in the cyber risk and resilience team at Monash Uni.
Good afternoon. My name's Andrew Fitzgerald, and I'm one of the Active Directory engineers, part of the core authentications team. And what we're going to talk about today is why AD security matters, the anatomy of AD attacks, the Microsoft Enterprise Access model, the Monash AD v3 model, and at the end we're going to talk about some quick wins that you can use to harden your environment. Please feel free to take photos throughout the presentation.
Sweet. Thanks, Andrew. So I guess to start off today, who here has Active Directory in their organisation? Who feels comfortable saying that their Active Directory is completely secure? Thank you, Tim. So the big problem with AD is that the defaults are outright dangerous. And this is for a number of reasons. So one of the big ones is that AD was designed in an era where we had a safe perimeter. The idea was that if you're on the LAN, the network you were secure and trusted. If you're on the outside, you're untrusted. But networks are not like that today. The second big one is that every single Windows client is a server, whether it's a server install or not. And every single workstation can do file, it can do print, and it can be remotely managed, which is a massive attack vector. Another one is that everyone can log on to systems by default. So, we talk about firewalls today and, things like that. It's a default deny everywhere. But with Windows, it's default allow for all authentication. So that's how you've got domain admin accounts that can log in and take control of an entire environment. And finally, it requires extensive knowledge to secure. And not only do you need to know all the different holes that an attacker can exploit in Active Directory, you also need to know how to fix them without disrupting the business, which is easier said than done. So how do these attacks work? Because I feel like before we dive into how to fix these kinds of attacks, it's important to get a bit of a mental model of how people actually attack Active Directory. So the first one I wanted to start off with today is looking at the attack surface of a typical Windows install. So you've got two main services running. One's SMB, so your file sharing, which by default has a few shares, your printers, your fax machines, if you still have those, all your operating system drives, and a special share called the admin share, which goes straight to the C drive. And that's before you even start adding your own file shares. Then you've got RPC, Remote Procedure Call. And this is a way to be able to remotely control systems on other machines. For example, services remotely edit the registry, remotely shut down machines, remotely schedule tasks. Who's used PSExec in their environment? PSExec works by actually putting a file in the admin share, and then it just uses Service Control Manager to start that as a service remotely. So as an attacker, that's how you can just move through an environment. You don't have to use PSExec, you can use whatever you want. But Windows has about 100, I think on last count, about 100 RPC services turned on by default out of the box. So if computers can talk to each other and they can authenticate to each other, that's how ransomware spreads. So attackers use these features to laterally move throughout environments. And this happens very quickly. So some data came out with CrowdStrike's Global Threat Report last year. On average, it takes an actor about 60 minutes to break out in an environment where they're able to start moving laterally, start taking control and getting what they want. This is a pretty simple process. So, they do some open source intelligence or find some breach data about the environment, get an entry point, then they'll get some initial access. So maybe it's phishing, maybe it's some stolen credentials, they get a foothold in the environment. Then it's this back and forth between two different parts, which is privilege escalation. So that's maybe locally, so they manage to dump credentials on a machine, get on a machine that's already running with another user's privileges. Then they use that to move laterally. So they use the things like we just talked about before, RPC, SMB, to move between machines in the environment and go back and forward, getting credentials and figuring out moving until they get to a place where they've got what they want, which might be data, it might be access to the environment through something like an SCCM, where they can push out code and either do things like ransomware or extract data, exfiltrate data. So it's a pretty simple process, and in some cases, CrowdStrike saw organizations being this process only taking roughly 2 or 3 minutes, which is crazy. And I think the big thing that is a common misconception is that ransomware and exfiltration events happen because all of the users have local admin. Am I recommending you give all your users local admin? No, it's a great thing to start reducing. But the big problem isn't actually the end users. It's that IT accounts, service accounts, and especially IT admins have overprivileged accounts that the credentials are stolen and they're used to move laterally throughout an environment, tear throughout an environment, and take over. And then they're also used to move upwards in an environment and escalating privilege. So what does a modern Active Directory look like? So there's a few different things that we could be covering today to kind of explain how you can secure an Active Directory of your own. The first one is something called the Active Directory tiering model, which Andrew's going to cover to begin with, which is a model for separating privilege in AD. The next is strong authentication mechanisms and protocols, so turning off all that legacy stuff that Microsoft loves to keep around. Hardened workstations and servers, so ensuring that there's those controls in place to protect machines from each other. Strict role-based access control and delegation, so rather than giving everyone domain admin to do simple tasks, being able to delegate those out in a really fine-grained way. And the final is just-in-time access to prevent users from having standing admin permissions throughout the environment. So I'll pass over to Fitzy to give a bit of an overview of the enterprise access model, so starting at the tiering stage.
Cool, thank you, James. So the first hardening technique the enterprise access model basically is a good hardening technique that we'll cover today. It used to be called the tiering model, but it is now known as the Microsoft Enterprise Access Model. So this model provides a framework for securing privileged access across on-prem AD, the cloud and beyond. So today we will be exploring the model and how we have implemented that into our AD environment. So the enterprise access model introduced tiering. It's a model of splitting up AD into different security domains and putting accounts, groups and computers into different buckets based on how much control they have over the environment. While it's a bit more theoretical than practical, it's usually implemented using complex group policies and ACLs in AD. So the core concept is fairly simple. Sensitive credentials shouldn't be exposed to less trusted machines. In other words, authentication goes up. Machines that control other machines should be protected, so in other words, controlled down. So tiering is a good, better than nothing approach to hardening Active Directory environment. When implemented correctly, it ensures that privileged accounts or services are not exposed to less secure systems. So what do the tiers actually mean? So generally we see 3 tiers. You've got tier 0, which is your control plane, or the crown jewels of a domain. That usually contains domain controllers, domain admins, PKI, DC hypervisors, as well as other tier 0 privileged accounts. Tier 1, the management plane, which services that manage other systems, such as like SCCM, file and print servers, backups, SQL, workload hypervisors, and other tier 1 privileged accounts. And then we got tier 2, which is the workload plane where your workstations and general servers sit. So in this model, for example, a domain admin can't log into a workstation and an end user can't get into a sensitive tier 1 system. So if a privileged user can't log into a normal workstation, then what do they use? So management in the tiering model is a highly sensitive task, wouldn't you agree? So we want to ensure that all privileged access happens on a trusted device. So this is where PAWS, or a privileged access workstation, come in. So a privileged access workstation is a dedicated workstation for sensitive tasks, and it gives administrators a secure device to work from. So a PAW is for management only. It can't be used for non-administrative tasks, such as email and web browsing. A user is given a day-to-day VM or SOE device so that they can do their productivity work. A POR provides increased security for admins working with high-risk servers and applications, and in many cases, certain tasks can be made to require a POR. For example, this might include managing AD, managing secure databases, managing services that can take control of an environment such as SCCM. There are PORs in each tier of the environment, so while a domain admin may have a tier 0 POR, a workstation administrator may have a tier 1 POR. In some cases, you might be carrying around 2 laptops with you. So what makes a POR trusted? It has restricted access to the internet, or in some cases, no internet access. It's always connected to a trusted network. It is domain joined and requires smart card logon. It is considered a trusted keyboard, and it is highly monitored and audited. So all in all, the use of PORs means that privileged credentials will only ever get used on secure systems. So talking about ADV3 in Monash University. So what is that? So over the last 2 years, we have been going through a major project. Internally, we call it ADV3, to uplift the security of our Active Directory. So this project had a few key topics in mind. We needed to make sure that we were reducing lateral movement. We had to contain an appropriate blast radius, have a unified structure of OUs, we had to secure privileged accounts, and we were tasked to delegate other tasks to teams without providing them excessive permissions. So keeping in line with principle of least privilege. So the Monash Active Directory team has worked tirelessly to bring together all of these goals to build what we now know as the Monash Enterprise Access Model. So with over 250,000 accounts, 40,000 plus workstations and over 2,000 servers, university has a very large environment to keep secure. Our AD is over 14 years old and has been through many iterations since it was first installed. So our new AD model, what we call ADV3, is the third major iteration of our AD build. And we've only just recently implemented this into our production environment around 6 months ago. So today we'll take you through some of the concepts we have implemented as part of our ADV3 project.
Great, thanks Fitzy. So I guess to start off with, what is the Monash ADV3 model? So basically it's micro-segmentation for Active Directory. So we're taking the tiering model that came out of the Microsoft Enterprise Access model and micro-segmenting it. So we split, we have tiers, which are levels of privilege within the environment. Then we have zones, which is where containers for accounts and computers, and they are little blast radiuses where we can keep those accounts and computers and stop them from authenticating sideways. And finally, we have services, which are targets for delegation that sit underneath each of those zones. So we'll dive into a bit of how each of those works in order. But the order is tiers, zones, and then services. So to start off with, the first new concept that we've introduced in the Monash ADV3 model is what we've called a zone. So the term zone comes from what we call a blast zone. And the idea is that they split big tiers into smaller chunks. So zones group accounts and they group computers together, and we prevent authentication between these zones. So by splitting up the tiers, we reduce the blast radius of an attack. So if one zone is compromised, we want to ensure that neighbouring zones that contain different computers and accounts do not get compromised. So really simply, if a bomb goes off in one zone, the neighbours are shielded from it, and we want to contain our compromises when they do eventually happen to the smallest possible container.
So a zone is an administrative control boundary. So for example, a workstation management zone, something you may see in Tier 1, may include services like SCCM. I am using SCCM as an example quite a lot. We've got printing and file servers as well. So all of which are used to manage and administer features to Tier 2 workstations. This would be separate from, say, our server management zone, which may have its own SCCM instance. So when we zone our environment, it has let us protect our environment from itself. Implementing zones reduces the potential for lateral movement throughout AD and lets us properly enforce least privilege. So how do we actually protect zones from one another? At the core of the zone model is a little known AD feature called authentication silos.
So hands up who's heard of an authentication silo in Active Directory before. So they're not very well known, but they're new-ish. They've been there since Server 2012 R2, which I guess is new-ish in Microsoft terms. But as great as they are, they're not really widely implemented because one, they're complex to set up. Two, they lack a lot of documentation, especially from Microsoft. And three, there's not a lot of literature out there about them being used in production. So today we really wanted to pay it forward a bit, change that, and release a bit more information about how we're using them, along with some resources that we'll release at the end of this talk. But in my opinion, they're one of the best protections that AD has at all for protecting lateral movement. And they deserve a hell of a lot more attention than they get. So what is a silo? So at its most basic level, they're a bucket that you put a group of users or a group of computers into and say, AD will not let authentication happen where it's not supposed to. So there's two main types of silos. First is a computer silo. You put a bunch of computers into it and you say to AD, these are the users that are allowed to log in. That's it. And AD will enforce that at the domain controller. The opposite is true as well. You can make a user silo, which is where you put in a bunch of users and say, these are the only places these users can log into. And that's it. Once that silo is enforced, Active Directory will stop authentication where it's not supposed to happen. So for example, being able to enforce that a domain admin is only ever allowed to log in on a domain controller, even if you have their credentials in your hand. So it's a massive, massive change to AD, and especially considering it's built right in.
Yeah, so as James said, the authentication silos are complex and difficult to understand initially. So having a dev or a lab environment was our best tool in understanding the use case for authentication silos. So we spent weeks and months doing trial and error to try and better understand ways of implementing this in our production environment. So yes, I agree with James that it is one of the best protections AD has to offer out of the box and is well worth the blood, sweat and tears. So in our case, we have implemented some very fine-grained authentication silos and policies. So like James said, we have poor silos, one in each tier, which we use to enforce which privileged users can authenticate against a poor device. We have then user silos, which are broken down to our zones. So we've got zone user silos. And based on each zone, we're enforcing which zone account can authenticate against which zone server or computer. So as another example, we've got zone 1C, which is like our workstation management fleet. I've got a privileged account there. I will only be able to ever authenticate against another Zone 1C server or a Tier 1 port. And in the inverse, if I were to try and authenticate against, say, a Tier 0 object, either PKI or a domain controller, I would get blocked by the authentication firewall. So how does this work?
So in the back end, basically, silos use this thing called FAST, and FAST stands for Flexible Authentication Secure Tunneling. The idea here is that by default, the only thing that's securing a Kerberos connection to the domain controller is what's called basically your password. That's how Kerberosing attacks work. There's a lot of issues with it. So FAST basically gives you this thing where it's a secure tunnel between you and a domain controller, and that's using a second factor, which is the device's identity. So FAST gives us something called armoring, which means now that we have this secure tunnel, AD can put in some extra claims into the authentication, which those claims include information about the device you're logging in. And all of those two things together give an AD feature called compound authentication, which means that the domain controller, now that it knows who you are and what your device is, what device you're coming from, is able to make authentication decisions based on those two things together, rather than just, are your credentials correct, but also, are you logging in the right place? And in order to turn this on, it's one GPO that you can apply to your domain controllers, one to workstations. And this has been there since Server 2012 R2, so all Windows 10, Windows 11 machines support it, all Windows current supported Windows servers support it. It's a couple of GPOs to just turn it on, which already lifts up protections, but then silos is just an optional feature on top of that to actually enforce it. The other main thing we have is URAs, so I'll pass over to Fitzy to discuss those as well.
So although we have the authentication silos and policies which control the authentication for privileged users, we still need to ensure that we restrict the access to non-privileged accounts as well. So yes, we've got silos and user rights assignments, and they work in tandem to ensure that the right account has access and authentication to the right service. So the DC handles the authentication, while the server will handle the user rights assignment. Now, in our case, we have some top-level deny rules which are enforced. They, like I said, applied at the top level. They are non-negotiable, and each service owner is then responsible for creating their own allow rules. So, as part of the authentication process, it is verifying that the individual or a device is indeed who they claim to be. So it's asking, are you really who you say you are? The act of authorization is granting permissions to an authenticated party. What are you allowed to do once you've proven your identity? So that specifies what the authentication account can and can't do. So now that we've gone through how zones are implemented, we then move down a level to services. So what is the service?
So the idea we had is we've got these zones, so they're big macro zones. So for example, you've got workstation management that's separate from server management, which is a great split. But we started to realise too that maybe some people in the server management zone don't need to manage every single server underneath it, or they only need very, very specific permissions. So we came up with this model of services, and the idea is that we can delegate permissions down to specific users. So for example here, we're able to split out in say a tier 0, there's a service for directory services, so management of the domain, and a separate one for PKI, which means we can delegate different people so that certain people may have permissions in the PKI space that they don't have in the domain space. So this allows us to give a lot more fine-grained permissions over to our administrators when we need to grant them a privilege.
So you may look at AD tasks as being primarily domain admin tasks. But what if I said to you that other team members can perform specific tasks in AD without giving them that level of domain administrator? So in our AD, we automatically create a large number of delegation groups for every single service. So these groups are given the fine-grained permissions to perform those sensitive tasks. So for example, a user can be allowed to join a computer to their own service, OU, while not being able to modify existing computer objects. A user could manage groups in one service, but not another. And a user could read BitLocker keys in one service, but again, not another. So because these permissions are delegated to groups, not people, we can keep AD ACLs tidy and make permission much easier to audit. So at the same time, we can make sure that the smallest possible set of permissions that are required to do a job are set. So on the topic of permissions, one big problem still remains. What if users don't need these permissions all the time?
So I guess in many environments, there's a big problem, which is that once you get access to an administrator's account, say all these protections are in place, they have standing permissions. So they have, say they can remote desktop into any of the servers in the environment they want at any time and do whatever they want. And that's a big problem because suddenly, even if you've got this account really protected, if it's compromised, it's game over because they have these long-standing permissions. So a couple of years ago at Monash, we went through a project where basically we removed, especially starting in our server fleet and then through to workstations, removing local admin rights permanently, and they all come through just-in-time access. So the idea here is that we grant our administrators the ability to request access to a server when they need it. They log into a portal, they're able to type in, this is the server I want to do, They provide their MFAs, that might be with a YubiKey, something like that, and they'll get access to that machine for 4 hours. We use a tool called LiftNet Access Manager, which, full disclosure, I work on outside of my time at Monash. And what it does is it creates JIT groups for every single machine. So there's an AD group for each machine, which contains all the active local admins in that group. And it uses an AD feature called time-based group memberships, which is a Server 2016 AD feature that it's able to add users to AD groups with a TTL. So they'll get removed after a certain amount of time. So what we're able to do is suddenly say that even if these accounts get compromised, the best that a threat actor can do is get into the servers that that user logged into within the last 4 hours. So we have thousands of servers, and even if you stole some of the most privileged accounts in the environment, they wouldn't have standing rights to log into those servers, which is a massive, massive uplift. And I guess speaking of MFA on that topic, there is something I really wanted to highlight as well that I think is underappreciated. And that's that YubiKeys, they're around $50, can be used to log into Active Directory. Everyone's talking about passwordless, and it's great up in the cloud, but everyone forgets that Active Directory has had passwordless for a long, long time, and passwords are so last year. So in Active Directory, you can set up smart card authentication for any user. All it is you create an Active Directory certificate services template, and you can let admins self-enroll. You then enforce smart card login for that user, so it's just a checkbox in Active Directory, and that user can only log in with a smart card. This is also a great time to audit ADCS, so there's a great tool from Trimark called Locksmith that can audit the permissions on those templates. But the big thing here is that suddenly you see all these attacks in the news where a domain admin password was stolen. In our case, we don't have domain admin passwords, which does get confusing with audits when they ask how complex the passwords are and we have to say there isn't one. But it is a great way to quickly uplift your environment, especially for those really privileged accounts. So if there's one thing you take away from today, go get some YubiKeys, and especially for your DAs, just move them over to smart cards, because it is a massive win that is a really low cost uplift. And I guess to kind of go through a high-level view of this AD model, and this is probably the writing's a little small, so don't worry too much, but the idea here is that we've got kind of like a nesting dog kind of model. So up at our tier 0, we've got things like our Active Directory and PKI in one zone. Things like our identity management is split out from that, so things like your Azure AD Connects. Then you go down to your management plane, which is where it's systems that control other systems. So for example, we have a workstation management, server management, Linux management zone that have tier 2 zones underneath them that they control. But also things like our infrastructure zones, our security management. All of these different areas of our AD are segmented from one another. So if we have a compromise in the server management zone, it's not going to be a great day, but it's a lot better than losing our entire environment. And for us, being able to also move all the way down to those workstations and know that in our model, workstations can't authenticate to other workstations. They've got SMB and RPC turned off. But they're also in this zone model where we can ensure that you can't have lateral movement between them. And that's not just enforced at the endpoint. That's not using third-party tools. It's using built-in Active Directory security controls, which is a really great, something I really love. And I guess on this as well, we have silos and zones at every single tier. So the control plane, the management plane, and the workload plane. And if one of these zones is breached, the higher tiers are protected, so there's no way to privilege escalate from a tier 1 to a tier 0. Its neighbours are protected, so if there's a compromise in the server management zone, the workstation management zone is okay. And finally, the only things that are really going to be affected are the things that it has control of, which is containing that blast radius into a much smaller area in the event that when a breach does happen, it is a much smaller blast radius.
So I'm going to go through a couple of slides here that basically show what we have implemented inside of Monash. So as you can see by the screenshot here, this is our top level of our OU structure. So basically each OU is the same. We do have different letters and numbers based on the zone that we've created. Each tier model basically has a collection of OUs. So we've got groups, which are security groups that are delegated around the tiering side. We have pores because we don't go down a level to creating zone pores. They're all tier pores. And each zone is a different group of services. So we've got Zone B, which is like identity, Zone C, workstation management, Zone D, server management, etc. So expanding on the zones, once we break it down further, you can see that inside of each zone we've got accounts, which can include user accounts or service accounts, as well as groups. And then we've got under the groups we have zone service groups, which basically give us the ability to delegate different tasks within that service. So this structure is exactly the same across all zones to ensure a consistent model and is applied to all of our environments. So one of the hardest parts about maintaining Active Directory is keeping it clean and consistent. So in this project, we elected to use PowerShell to build as much of the directory as possible and maintain it once it's deployed. We have created a PowerShell module which distills concepts like tiers, silos, and zones down to simple commandlets. So as well as keeping production clean, this means that we can repeatedly apply the same configuration on top of the directory, be it production or any of our development domains. So the script is repeatable and it gives us the ability to repair any config drift that may be discovered after implementation. So we play them through all of our environments, starting with dev, and then we do those testings, then we break it down to our other dev environments, QAT, and then finally production. Big tip, never go straight to production. Things can break. Anyone broken anything in production by doing that? Yep. So yeah, definitely dev environments if you're looking to implement something like this so that you have a good understanding of how it's going to impact production. So also to assist in maintaining our AD, we also have monitoring and cleanup scripts. So that ensures that the environment is set to our standard deployment model. So we've got scripts that ensure that ACLs stay clean, bouncing any rules that shouldn't be there, or any users. It ensures that our admins don't have their passwords enabled, so that toggle that James showed before about enforcing smart card logon, every night that is scanned across all of our privileged accounts and that option is selected. It also bounces users out of privileged groups. So if someone has managed to get themselves into a higher security group, the event is actually monitored and we've got parameters inside of that script that will bounce any unauthorized user from being in there. So that's just to name a few. So to wrap up today, we've put together a small group of quick wins that you can take with you to improve your security footprint of your on-premises Active Directory environment.
Sweet. So the first thing I want to say is take a photo. So there's two parts of this. I'm going to run through some of the quick wins, but the other one is this QR code. I know telling security people to scan a QR is a bit dangerous, so there is a link underneath. But on our GitHub, we've put up today a bunch of the resources that we're about to talk about in the quick wins, but also the full model of our Active Directory that you can take home and look at yourselves. So I guess for a level 1, there's a few really quick wins you can take in Active Directory security. First is using something called the protected users group. Basically, it means that any users in that group disables all legacy authentication protocols for them, and it means their passwords can't be cached. It also disables delegation. So it's one of those things that, like in the previous talk, there's issues where if you turn on these features, sometimes it will break things. This is one of them, but for privileged users, it's very worth it. Moving to smart card login for privileged users, go get some YubiKeys. They're really easy to set up, and it's a great win. There's something called Lithium AD password protection. It's open source and it's able to, say, compare your Active Directory against have I been pwned. Very, very useful tool if you've still got an on-prem environment. Using laps to rotate local admin accounts on computers. The biggest problem in a lot of environments is the same local admin password everywhere. Go turn on laps, back it up to either Enter ID or on-prem AD. And use user rights assignment rules just to block things like domain admins. Your domain admin should not be logging onto your workstations. Things like that. Enforce those rules globally. They're a really easy win that you can start off with. Level 2, cull your tier 0 accounts. So there's some organizations that have 10, 20, 30, 50, 100 domain admins. It's just terrifying, personally. Monash has 4 domain admins total. If you have more than a handful, start looking at those kind of areas and the ways that you can start reducing the amount of access and delegate that specific access out. For example, a domain join account does not need to be a DA, you can delegate that permission. Passwordless GMSA is really cool. Instead of creating a service account that you always forget to rotate the password of, you can create a GMSA, AD rotates the password, and you can use it to run a service, run a scheduled task, without having to worry that the password's going to get compromised or kept in someone's, kept plain text somewhere. Look into turning off SMB and RPC for your workstations. If your workstations are being managed by something remotely, or like they've got an agent, they don't need, probably they're not running file servers, they're not running all these different services. You can probably start looking at ways that you can just use a host-based firewall to turn them off. Look at ways to implement JIT for your servers. Just-in-time access is really great. It stops people having standing admin access. And also things like rotating KRB TGT, it's the account and AD that issues all Cobros tickets. It's really easy. There's some scripts from Microsoft to actually rotate it automatically. And then finally, getting up to level 3, so start looking at tiering by creating a tier 0. So that's your domain controllers, your PKI. Start protecting your most critical assets, and then start moving down into those lower levels, like your tier 1, where it gets a bit muddier. And then also look at ways to investigate pores. You shouldn't be using the same machine you're on Facebook on, you shouldn't be a domain admin. Try looking at ways that you can split out those use cases and things like that. But I guess with all of these, the big thing here is that this takes a team, right? This is not something that you can do by yourselves or even your own team. You need that buy-in from the organisation. And on that note, I really wanted to pass over to Fitzy to say some thank yous.
Thank you, James. So yeah, like James said, it does take a team for us to implement this uplift. So we've had a number of users, past and present, who have put a lot of hard work into this, especially over the last 2 years. Everyone's had different ideas, different ways to enhance our security. So yes, I definitely want to thank our team for contributing as much as they have in this security uplift. I'd just like to say thank you all for attending today, and if you have any questions, feel free to reach out to us. We are about to go on lunch, so yeah, more than happy to answer any questions that you may have.
Excellent, guys. Give them a round of applause. Well, there are lots of questions, hey? So maybe I'll give you one or two now, but maybe over lunch they can shout you a free lunch. So I guess one of the questions were, you sort of answers, how many people actually look after AD at Monash?
So yeah, like James said, we've got about 4 full-time domain admins, but we do split up certain tasks within AD. So we have FIM that manages the lower levels for identity. So any new tier 2 accounts get created by FIM. It's all managed in a secure environment. But overall, yeah, it is only 4 domain admins at a time that looks after AD.
Another question was, if you only use YubiKeys for domain admin accounts and no passwords, do you also have like a break glass account in case?
Yeah, definitely. So we still have a break glass account. Again, we don't store that on a YubiKey. We have a massive password, which is stored in a safe in multiple locations, so that we don't have it all in one area. And break glass account is excluded from a lot of the tidy up scripts that we do have, because we don't want it caught up in anything that, I guess, toggles it to forget the password and weeks or months down the track when we actually need the break glass account, we're up the creek without a paddle.
Yeah, sorry for asking all like the secret sauce questions. That your extra threat actor, like, which is the students at Monash, right, will be watching this one day. So maybe over lunch you can have a chat. So yeah, I want to thank these guys again for a great talk.